this is Steve Tennell, Ventilation Matters, and tonight we're joined with Geoff Chase, Jeff Shaw, Patrick Tan, Ross Freeburn, David Wilms, Graham Acorn, and myself. We're going to discuss safe doubling of mechanical ventilators, and that's an important topic here in COVID times. Not that we would do this in normal times, but it certainly is an issue that has thrust itself forward. Jeff, please take it away.
Great. So there's actually a short article on this in Critical Care, which I'll actually post through the chat here before I get out. Although it's freely available online, it's actually got that safe doubling of ventilator capacity, a last resort proposal for last resorts. So yeah, as you said, we opened our article pretty similarly with a quote from ourselves, which says that the best way to ventilate 2 patients on a single ventilator is simply not to do it. However, when you run into a situation where you run out of that, then of course, you need the next best way. So, as you know, in the beginning of COVID, lots of panic about ventilators, some of it quite justified in Italy, New York City, and now increasingly other places. And a lot of things appeared on the internet. Look, I've hooked 8 balloons for 8 different lungs up to a ventilator. And I just multiplied the tidal volume or the driving pressure in an appropriate fashion, and off I go. And so there were so many of these, and I think enough of an outcry that, as you probably also know, I think it was 6 different intensive care societies who might normally not agree or get along, published a list of 11 reasons not to do it in a consensus statement from the SCCM, the ASA, CHEST, AARCA, and so on. So, of course, the obvious thing, when you put 2 patients and you give them double the tidal volume, the stiff lung gets less than it needs, the more compliant one gets more, and you hurt both patients. So I was in a discussion with some colleagues, and we were laughing about this a bit, and said, oh yeah, but what would you do? And the answer comes from manufacturing and real-time mechatronics, which is that you have a duty cycle. A breath takes, say, 3.5 seconds at 16 breaths a minute, which is the favored number at Christchurch Hospital. So 1 second in, typically about 2 1/3, 2 1/4 out, depending on your preference for fractions. While the patient's breathing out, you can be doing something else with that ventilator. You can be breathing in with another patient. And so am I allowed to share a screen? Would you mind?
Yes, please.
It looks a lot like an article that came out of a group in Belgium that was looking at these things, with one critical difference. So you have one-way valves, you have filters, you can have a separate PEEP valve at the far end. If you want to adjust PEEP differently, you probably would only use one, because you would have the PEEP set to say 10, and the other patient, if they required 12, you would add on PEEP on one of the circuits. The big thing is this red dot here with an X. It's an active valve. And hopefully if I grow this, you can see this picture pretty clearly.
Yep.
In essence, you have 2 patients. So you would, if you imagine this as pressure control, the patient's sedated and paralyzed. One patient breathes in for about 1 second, and then you have the rapid drop, and then the rest of exhalation. And that exhalation would go all the way over to here. So about 1 second in, 2.5 seconds out. You can sense pressure with a small sensor in the line. Come on. In this active valve, and I'll show you some pictures. So that, come on, behave. You're breathing in the blue line. The other patient is breathing out from their last breath. You start breathing out through, oh Lord of technology. You start breathing out while the other patient's expiring, and then they breathe in. So you're switching the valve. So there's a piece where you're breathing in here, breathing out from patient 2. both patients are breathing out. Patient 1 continues to breathe out, and now patient 2 is breathing in. So what you require is a valve that flips from one to the other. And you can do that by sensing the drop in pressure after a breath. It doesn't matter when you switch in here, as long as you can switch and be ready for the next inspiration. So that is the essence of the thing. I can show you. I've set up a video. This is a prototype in action.
Yeah, very minimal self-impression.
And I apologize, this isn't rotated, but it's under pressure control. So pressure is constant along the top. And you can see there's two lungs.
You're using one of my favorite ventilators.
Yeah, they didn't want them anymore at Christchurch, so we got one. With apology, but in essence, what's going on there is that you had the constant pressure. If I go through this, oops, I don't think I showed the lungs, but I can show you a picture, which is easier. If I happen to have one. Here we go. This is the test setup. Once it shows up, you've got a big, more compliant lung and a smaller, stiffer lung. And so in that video, you would have seen the pressure was the same, pressure controlled ventilation, and the volumes were different. And in essence, it's what we call in-series breathing. I breathe, and then Stephen, you breathe, and then I breathe again, and we can breathe out together. And the ventilator doesn't complain about this with enough one-way valves. Jeff and I were talking about adding a bag so that you could actually wean a patient in the sense of letting them the paralysis wear off so that they could start trying to breathe and seeing what would happen before you wean them. Otherwise, weaning 2 patients when they're on the same ventilator, weaning 1 will be hard.
Like the old IMD bags, huh? So that would be
right.
somewhere on the inspiratory line?
The old
Yep.
H12 system.
Yep.
Aging.
Apparently, this requires a group of men over 50, which is maybe not a good sign.
That's right.
But in essence, this is close to the final design. I can show pictures all day, but it's entirely 3D printed. The designs will be made available in 1 to 2 weeks, along with all the software, the motor specification, and everything you need. And that was going at 30 breaths a minute. We've run that up to 46 breaths a minute. So that'd be 23 for each patient, which is as fast as the PDA 40 seems to want to let you turn the knob. But in essence, in parallel, you're trying to split a volume or pressure delivery in a way that matching lungs makes hard, especially because even if you match them right, patients diverge. What this says is you can customize each line to a good measure, and you breathe separately. And so the ventilator just does its thing at twice the rate. And that's the concept. I'll stop a share, but I would happily take any questions, or Jeff can answer any questions. We see this as something that you could 3D print, cheap motors, cheap O-rings, and a little pressure sensor. It's got a built-in measurement for pressure and flow, which we've correlated to the ventilator's measurements and all that good stuff.
And so the primary ventilator is set to a like a 2-second I time or something longer that you figure is going to be cut in half. What
exactly.
Okay.
No, it's the I time.
Sorry, the I times.
The I time has to be short, and so what happens is the ventilator might be set, say, for 30 breaths a minute, and you might have an I time of, say, less than a second, and so the ventilator would be ventilating 30 breaths a minute, but would be switching between 2 patients every second breath.
So rather than doubling the time, you're actually doubling the rate, it seems like.
Exactly.
And
So in essence, we've been running it at.
I'm sorry,
Yeah,
that drop in pressure triggers the flip-flop of the valve, or the flop of the valve?
Exactly. So there's a valve in the inspirator coming out of the ventilator. There's an active valve with a Y. And just before that valve is a pressure and flow sensor. And we can trigger off any wide range of conditions. But because you have a big drop in pressure, it's easy to see. You don't even need to know the pressure per se. You just see the big drop. But in essence, we've run it up to 46 breaths a minute, but at 40 breaths a minute, 1.5 seconds, you can actually play a bit of a game with it because you know that the expiration circuit is open. You can give it an inspiration time of 1 second like you might normally do. That only leaves you half a second for expiration, but it's only the inspiration side that's switching. So you actually have the whole 1.5 seconds of the other breath or part of it to breathe. So you can cheat it that way.
Yeah, it's probably important to conceptually understand this system has been quite different from the in parallel methods, because you can actually customize the driving pressure for each patient. You can potentially put in a restriction valve. So if you have a pressure control ventilation, you can put in a restriction valve that can drop the driving pressure from, so let's say you set the ventilator to 40 centimeters of inspiratory pressure and 0 centimeters of PEEP. So basically that's going to be like your reservoir pressure in the old Servo 900C, for example. And then what you can do is you could have a mechanical restriction device that drops at 40 down to say 25 if you wish. And then you can put in a PEEP valve, which dial up any sort of form of PEEP that you like. So for both patients, you can have something quite bespoke and independent of each other. Does that make sense?
Geoff,
Yep.
it looks fascinating. I assume that you're using a Puritan Bennett. I think the maximum inspiratory time is about 80%, I think, on the Puritan Bennett. And so therefore the maximum inspiratory time divided by 2 would be 0.4 of a cycle time. Is that right? 40% of the cycle time if you're trying to get 2 breaths out of the same machine. Is that correct? If your inspiratory cycle, the percentage time for inspiration is set at 80%, half of that.
Yeah.
Oh, sorry, your rate. But your rate would have to be, if you set your rate at 40, that'd be 20 breaths per patient. Is that right? And
Yes.
half. And so whatever your inspiratory time is, would have to be half of the cycle time, half of what it would be in the total cycle time. That's correct.
Right. So 40 breaths a minute, you'd have 1.5 seconds. You'd have 0.75 inspiration. Although you can run that up to close to 1, at least on this one. And you get basically, then you'd have 1 second in, half a second out. The valve switches, but the expiration line remains open.
Yeah, I think one of the limitations of this is that if we're using it for COVID or another disease that requires ventilation for hypoxemia, where one of the ways we combat hypoxemia is to prolong inspiratory time. The IA ratio is 1 to 1, 1 to 1.5. You've got a limitation on your inspiratory time that's limited to probably 40% of the cycle time in total.
You do. In that case, we'd suggest probably something, and I'll let Geoff answer because he's an actual doctor. But I'd say you go to 30 breaths a minute, 15 per patient, and 1 second in, 1 second out, 1 to 1 IE, or even a little bit longer.
Yeah, I understand, Ross.
I don't think it'll let you do that, will it? Because there is a limitation on the inspiratory time. It won't let you inspire the entire breath cycle.
It won't, but it'll let you inspire half of it.
Yes, that's right. So your limitation then is half of it. You try of 2 breaths, you're going to do 1 to 4.
Yeah. In essence, you do 1. If you did that, it'd be 1 to 3.
Yeah.
Because you overlap them.
Yeah.
Right.
I take your point that you might, in some cases, want to have a longer inspiratory time, and that would be, you could say that's a limitation. Equally, you can compensate that, and this relates to your mean airway pressure paper, by increasing the PEEP. You just got to PEEP for a longer period of time. So long as you're getting these cyclic changes in your gas inside your lung, within the limitations, I don't think that would be a huge disadvantage in having a very short inspiratory time, provided that you actually have a appropriate amount of PEEP, so that your mean airway pressure is preserved. If that's what you're thinking.
Well, except mean airway pressure may be harmful as well as beneficial.
True.
It's beneficial for oxygenation, but harmful for alveolar damage. So either turning a high peak or turning the tidal volume up to achieve that is going back to what we used to do, which is large volumes, large exchanges, and low rates, as opposed to it's the reverse of APRV is what you're doing, which may not be a bad thing, but it is a limitation. That's all.
I mean, finally, it's the first line of that paper, right? The best way to do 2 patients on 1 ventilator is not to do it. The next best way is going to have a compromise, because you could equally run in some more O2, but it's going to run for both patients.
Well, as long as the patients read the same book and they behave the same way, then you should be fine.
Oh, well, I wrote a textbook about that.
And have you thought about the Synchrony with that? How would that work with the? I assume you sort of paralyze these patients, are you? And it does make it easier.
Ross, at the moment, in terms of how far we've got, every patient has to be completely paralyzed and not even trying to trigger anything. So the only way forward from that would be to regard this as a bridge to getting another ventilator. But as Geoff and I were discussing, if you start to get a wave of COVID patients, the chances of getting another ventilator might not be immediate and might be weeks away. So we're going to be left with this sort of dilemma of, okay, we've got the patient on this ventilator, and my God, he's still alive, and that's better than the patient being dead. But oh shit, are we ever going to get them off this? So that's when we have to be a bit more creative and smarter in terms of putting in a bag and an assistant so they can take a breath from the inspiratory limb, should they wish to, and should we try to get them weaning on this particular device. But we haven't got there yet.
So what's a real shame here? This is a good topic, and we should have had either Rob Chatburn on with us. He's meant to be joining us sometime, because he's also published in the he and Rich Branson have also published an article on this as well. So it'd been great to have either of them at the same time, right?
There has been one article published on ventilating patients in parallel. It was out of a group in New York City. I forget the particular authors. I have put that paper up through. Interestingly, they had a huge and very complex patient matching algorithm, and they tried it out for, I think, 24 hours, and it worked pretty well by the look of it. I think the real problem here is that if you actually have run out of ventilators and every one of your beds is full, your time to get everybody matched and keep them matched is going to be rather short. What we liked about this is with pressure control, I can control the PEEP, the driving pressure for each patient pretty much independently. I don't get control of FiO2. I'm going to have to make some compromises about IE. And I'm probably going to have to do something with another valve to let you wean a little bit better. I had a conversation with some colleagues in Belgium, and like, well, we really don't like to paralyze them too much. I'm like, if you're at that point already, you've run out of ventilators. Belgians are pragmatic, you solve all that, but it's basically designed hopefully as a bridge. Somebody asked me, wow, it'd be really great if thousands of these get used. And I said, actually, it'd be really shit if thousands of these get used. But, but I suspect it won't be none. And, you go from there. Ideally, it'd be something that you run for 24 hours or less. And I have no idea, in fact, how it might be used. We'll be working through how to set it up clinically so it's easy. But it could be, Jeff's ICU is about half full during the COVID lockdown here, still with the normal number, the background rate, if you will, of ICU patients. It could be that you might have a couple of sepsis patients there for other reasons, and you double them up if they look more alike, and you keep your COVID patients on individual ventilators. There's a couple ways to skin that cat.
Just a full disclosure as well. When the picture came out in New York of the physician holding a circuit with the 840 in the background, I jumped on LinkedIn and I posted the picture and the article, and I listed about 15 reasons why it was a bad idea. And I was pretty aggressive in my commentary, having known the product and the products. And shortly thereafter, I saw that the ARC came out, and you'd mentioned this earlier, as well as Society of Critical Care Medicine, and a few other societies. And I kept waiting to hear something from one of my favorite societies, ATS. And I never had any, there was never any real comment coming from the ATS early on. And what that caused me to do is to stop and think for a second and go, well, you know, if, you know, stuff's up against the wall and you don't have a choice, then maybe we should think about how we can do this in a safe manner. In addition to that, one of the items that continued to be an issue for me is that of all the groups that have done this, no one, and this may sound, you know, trite or minute, but no one has addressed the issue of humidity therapy. And that's, in my opinion, equally important in treating COVID patients because of the duration of their, or the length of their ventilation. And so clearly when I looked at your circuit, I saw exactly where I'd put 2 humidifiers, and I didn't necessarily need to employ heated wire per se, but at least I knew that we were actively, that we could actively humidify these ventilated patients. So does anyone have any questions or anything they'd like to add?
Geoff, so you've got around the problem of the parallel thing with the changing compliance, both different compliances, but also changing compliances, which is the big problem with using 2 ventilators on 1 patient with a single circuit. I think that's a great way to deal with that. But I still think there's a limitation on the fact that you'll be, inspiratory time will be limited. But
we're going to have a good thrash through. So what will happen is this will all be made publicly available on a variety of Makerspace and other places, and I'd be happy to send it to you, Steve, and all of you to distribute to whatever networks. And the goal isn't to make money here or sell something. Along with full instructions. Part of that will include a video of Geoff and one of his less engineering-oriented colleagues, how to set it up, how to use it, and how to thrash it, so that people are comfortable with some of the questions you're asking. Because we played with it with 2 bags, and Geoff's had to play with it and thrashed it modestly. But you know, you want to go through it, and some of the feedback here has been really good in terms of, all right, well, let's see, you know, how much can we make this do?
Hey,
I'm curious about the alarming. What kind of issues did you deal with the ventilator alarming? And
that was easy.
We haven't had any alarming unless you make the PEEP far too different from one side to the other. Then you start to trigger the blockage alarm. Interestingly, it does not always seem to alarm if you put added PEEP only on 1 circuit, because one breath it sees is fine and the next one it sees is a little blocked, and then the next one is fine. Anyway, I don't think anybody thought ahead about somebody doing this.
Did you have any disconnect alarms? No.
Nope.
Good.
So would the main alarm be the minute volume alarm, would it? So you have to have quite a large amount of volume, I'm assuming?
Haven't seen it.
Just in terms of the alarms, I think in maybe a future iteration, we'll build in software for each patient to have their own alarm system in it, rather than and then defaulting to those alarms and switching off the alarms at the ventilator might be the only way forward. Because the truth is that we haven't examined all the alarm conditions with this, and there may be some significant problems there. So the simplest workaround is simply to have an alarm that's based on the actual mechanics of each individual patient. Can I just go back to Ross's comment? Because I think Ross has got a point. regarding the fact that you have a limitation of the inspiratory time. What would be really cool, and I haven't seen this published, but is there a good reference paper that has the respiratory mechanics of typical patients with COVID, or even typical patients with ARDS or whatever, so that we can have a look at the population of patients to address which patients would not be suitable to this multiplex ventilation system? It might be there are 5% of patients who do need a long inspiratory time. I don't know the numbers, but I'm just taking Ross's viewpoint that it would be really nice to know that this is going to be good for X percentage of COVID patients should they come forth. And the patients that would not be suitable, if you're trying to select which ones you're going to multiplex, would be those with these mechanics, if you know what I mean. So has anyone got any idea how we can approach it that way? Because that would be really quite useful to select the appropriate patients who are actually going to be able to have a relatively short inspiratory time, if that's going to be part of the, I guess, the compromise of running this system.
I've read around whatever comes out, and it seems like there's two kinds broadly of COVID patients. One that requires very little PEEP and maybe is better off with non-invasive, and one that looks more like ARDS. As usual, they don't come pre-labeled. And that was paper by somebody in Gattinerney's crowd out of Italy.
Pelosi.
They were published. Pardon?
Pelosi.
Yeah.
Pelosi was it was one of the authors. Yeah.
Yeah.
That's the only thing I've seen on mechanics. It wasn't sort of just my experience and a bit of speculation.
Geoff Chase, what I'm suggesting is that it's almost akin to how we started doing virtual patients in the insulin, in the diabetes setting, and running them on STAR. I wonder if we could find somewhere a database of different respiratory mechanics, or at least making something up based on the best information we have, so that we can then simulate patients under the conditions of having a multiplex ventilation. If you get my drift.
Available for COVID. As you know, we have the models sort of to do that, and that's the future. But maybe. But I haven't seen anybody that it's not on the Mimic database, things like that in the U.S. And they don't usually have ventilator waveforms anyway. People just don't sort of see the value of this.
Steve, is there any publication you are aware of which is published, broadly speaking, what the ventilator settings are in a large cohort study, either as an observational study or part of an RCT?
I haven't seen anything, and again, my mind migrated to the highs and the lows as a initial indicator potentially, but I'll keep my eye out. I'll keep my eye out for that. I don't know if anyone else has seen anything yet.
It's interesting.
Jeff, there's probably nothing you can use in the sense that if you look, I'm just trying to find the slide to share with you, but the original ARDSNet study, you look at the parameters in the tidal volumes in the first, I don't have it here, sorry, in the first 4 days, the patients that had a tidal volume of 12 mils per kilogram rather than 6 mils per kilogram had a much better oxygenation ratio. And so look here, the mechanics, looking at the short-term parameter, mechanics or ventilation or oxygenation, and saying this ventilation strategy improves oxygenation does not result in a better outcome. And that's would be my concern. If you said, look, I can ventilate this patient on short inspiratory times compared to and get away with it, it doesn't mean the outcome is going to be beneficial. In the ARDS study, if in the first 4 days, those who got the 12 mils per kilogram looked like they're much better oxygenated. And if you ask anybody, they were doing much better. The PO2s were much better, but their outcomes were 10% worse. So I think the same would apply if we tried to do the same thing with COVID and say this ventilation strategy gets better oxygenation with shorter inspiratory times. I don't think we can make that jump.
No, I'm just basically not trying to make any jump. I'm just trying to ascertain what clinical practice is in the real world.
Oh, you know, fair enough. Yeah, it's,
Yeah.
um,
Yeah.
I think the question, Jeff, is about having inspiratory time discussion is actually a whole topic by itself because of you know, again, what Matt presented the other week about an eye time of like 0.8, and I'm not convinced why you'd want an eye time so short if the patient is you know, he's on the ventilator. You would think he's either breathing himself or he's got a high rate. So if you have a longer eye time, and I don't want to take away Ross's topic of mean airway pressure, but if you have, for example, an eye time of 2 seconds, PCV approach, the ability of mean airway pressure should increase based on the rate, but also too, your CO2 clearance should be better, right? Because you've got better distribution of volume because of your inspiratory time constant. I think short eye times, they have their limitations.
They will in some patients. That is true.
yeah, that's true.
Thank
Thank
you.
you, Jeff.
Thank you, guys. Appreciate it.